Good. Okay. So what we covered was inheritance. Okay. Now we will see some tricky thing that people will always ask you on inheritance. Okay. Is a simple questions or most of the questions that people will ask you, right, on inheritance. Okay. We can actually go through them. Okay. First one. Let me come into this. Okay. Okay. So inheritance and RTTI. Or people will ask you interviews on questions on RTTI. So what does RTTI mean? Or uh, this has something to do with the virtual functions and all. Okay. So what does RTTI means? Runtime type identification. Runtime. Okay. So what does this is? Runtime type identification means you are trying to identify the type of an object in runtime. Okay, you are trying to identify the type of an object in runtime. Okay, so you when I say you, it means the application or the code that you have written is trying to identify the type of the object during runtime. Okay, so using this you can achieve a lot using RTTA concepts and all. Okay, now we will go through small examples when and how it is used. First, we'll try to create a couple of objects. Okay, so what do you see here? What kind of code you see here? So here we just see two objects has been created. Okay, when you created the object, you just declare them as if it is a base class, and you created an object by name derived class, and you have specifically mentioned it as derived class. Okay, you just mentioned it as derived class. Okay, so during compile time itself, see here, during compile time itself, you have specifically and clearly mentioned the types of this object. Okay, or you can call this as static polymorphism, or it is not polymorphism, it is like compile time type identification. So, okay, whatever that you are done here, right? You have made them, this is compile time type identification, wherein during the compile time itself, you have clearly mentioned what is the type of this object. Okay. Now these are not pointers. Now these are just a simple variables. These are a simple variables. So for a variable, the type are identified because the objects are created during compile time itself. Okay, you everything is fine. So the compile time itself, you can only assign the type of this. Now, what if I try to make this as a pointer? So I just made this as a pointer. Okay. Now what I can do, I can assign this to null. Okay. I can assign this to null. Now I just created a pointer. I assigned it to null. Okay. So what is this pointer pointing to? It is pointing to null, which is nothing but zero, and it has no type associated with it. Okay. Let me undo and just keep my code. Just put this. Okay. So here I created a pointer of type base class. Okay. So whenever we create a pointer of base class, what we will do or what we can do is simply we say that we'll just allocate some memory to it is equal to new of base class. This is our general assumption or uh, general way of coding, right? So you created a pointer, uh, okay, of base class, and you just created an object of type base class and assigned it to a pointer. Now this pointer is pointing to this guy. Okay. Now this pointer is pointing to this guy. That's what we made. So see, now the type of the object is assigned when. Now the type of the object is assigned when during runtime. Okay. During runtime, you can assign an actual object. Okay. During runtime, you are creating an object and assigning to it. Then if you check the type ID, okay, this is something which we did in chapter 1 where we are trying to identify the type of an object during compile time, during runtime. Okay, now we will see what is the behavior. Okay, what should be the behavior here in this case when you print line number 64? Okay, I'm not printing at all anything. Okay, if you see our, I think chapter 1, right? Somewhere we have used type identification or type name. here. So based on the data type that we passed, we were trying to print the type that it has been passed. Okay. So we are trying to identify the type of the object in the runtime. Okay. So what do you think the output that should be here? Anyone want to answer it? You can just take a guess. It's fine. Nothing. There's nothing to lose. Anyone? Sakalya or Guru, Smita, you can answer this. Yeah, all of you are on mute. Anyone can answer. Okay. So if you see here, right, you haven't actually assigned any object to this. So it is just a null. So this can be something like null pointer or invalid object type. Okay. But here, okay, but here you assigned an actual object to it. So during runtime, uh, based on the object that it is trying to point, right? Okay. Now if you assign it as a base class, it will print it as base class. Okay. Now let's just compile this and see what just happens.
Sorry, sir, I'm not able to unmute that time.
Okay. Okay. So maybe you can answer now.
Yeah, that null value only it will be
null
uh,
वैल्यू का कुछ
so
टाइप होता है
no,
देखते हैं we'll see what this guy says. See, it throwed an
but
exception.
yeah,
It throwed an exception.
and we can call to
This is an
bit type
exception.
ID.
It's just a core
No,
dump. Okay. Now we'll see whether this got core dump or this. Okay. Why this happened is because this is null. Okay. Null ka star means memory address of zero ka star. Okay. Which is pure violation by Linux. Okay. In Linux will not allow you to use an address which is not assigned to you. Okay. Null means zero. In your memory address, what is the memory that is pointed at zero? Generally, it would be recept or interrupts, right? That is purely read only. So that section you will not have any access to do. Okay. Okay, now I commented that and I see. Now you see what is the type of the object. Now you don't see a crash. You see only one output that is here stdcout type id dot name. Now what is the type of this object? It is base class. Okay, base class scoped object released. No, no, this is
so
some.
what is 9 base class?
I'll tell you it. Okay, 9 base class. Okay, so I'll tell you what is 9 here. Okay, generally when you create any new data type, whenever you create a new data type, for that they will the C++ will add an integer at start, okay, and then followed by a name. Okay. So similarly for ints, it was printing I, something like that. Okay. Now we can add those examples and see here. I think we did this in the start. Okay. Now I'm trying to print the type name of int. Let's see what it prints. For int, it gave a name as I. Okay. The name for ints are I. Whereas for base class, okay, for any class that you create, it is saying 9 followed by some name. Okay. So this is a name that compiler has given internally for base class. Okay. Some integer followed by some name. Okay. Am I clear on this? This is what compiler gives. That is not something which we can say. As per their compiling coding standards, they are giving some names to whatever the data types that you create so that they can compare them. Okay. Now let's see.
Sir, one thing, how is it compiled means whenever we go to that STD out, that 64 line, uh, without
Line
commented,
number
it is coming that is okay,
62 line. What
64,
did I do?
64, 64.
Oh,
Without commented, it is coming like a, means it is throwing some uh,
exception and crashing.
exception. Yes, classroom.
So it
But
is not
here, how is it calling? Means how is it compiled
here
in
line
this
number
type
71
of?
we added na. So we commented this line.
Mhm.
Then for pointer we assigned an actually an object. This pointer is pointing
Okay.
to some physical object.
Okay.
Yeah, you did a new, right? You created a new object
Mhm.
and assigned
Mhm.
the address to this guy. Okay. Now we are just asking, what is it this guy actually pointing to? ओके ये किसको पॉइंट कर रहा है बेस क्लास को पॉइंट कर रहा है या इंटीजर को पॉइंट कर रहा है या समथिंग एल्स we are it is pointing we are trying to do is see the the scope of this class is identifying the type during runtime. Okay,
Mhm.
so you write a for loop to which you are getting an object. Okay, in C you would write void star. You would write a very generalized question saying that void star. So what would it say? It is just a memory. I mean, it's just pointing to some address. That's all.
Mhm.
Okay. So you're not able to identify the runtime type of the object in runtime in C, whereas in C++ you can identify what is the type of it. So we are trying to identify the actual type of the object here. So we were able to identify it as base class. Okay.
Means any number it will come. Means it was
It
coming
can
like
be
nine
number
best class, right?
99.
Means
So generally it will be a common number. Okay.
mhm.
9 and base class. Now, no matter how many objects you create, it will still remain 9 base class.
Okay, okay. Means
Okay.
nine is fixed, you are saying. Means
So 9 is
anyhow it will
fixed
come like
for the first object that you are creating. Okay.
okay.
Maybe derived class can get 10.
Mhm.
Okay. We'll see this. Okay.
Why it is means why is it like this? Means
Oh,
best
compiler.
class is
Compiler,
having
they have developed like that. Compiler
okay,
are giving
okay.
some names to a class that you
Mhm.
have developed.
Okay.
Who will convert your code to machine language or assembly language? It is the compiler. So whoever wrote
Mhm.
that GCC compilers, right? They tried to give some names. That is as per C standards. Okay.
Yeah.
Now
This one is
this
G plus plus, right? Yeah.
what sorry, C plus plus,
Yeah.
GCC or G plus
G
plus.
plus plus. Mm-hmm.
Yeah.
Yeah, G plus.
G plus plus is a pure C plus plus compiler, whereas GCC is a C
Mm-hmm.
and a C plus plus compiler. Okay, but we would prefer to use G plus plus because if we put GCC na, it will come,
Mm-hmm.
and if your file is a C file, it will compile it in C way. Okay, but we don't want to do
Mm-hmm.
anything with respect to that. Okay, okay, we'll come back. So now base class
Mm-hmm.
is pointing to, no, the pointer is pointing to base class. Okay, now can we do any magic here? Okay, so one important feature that C++ provides us is, okay, a pointer of base class can point to the base object and also a derived object. Okay, the pointer of a base class, okay, this is a pointer of what type? A base class type. It's a base class type. What we did here, we made it point to base class. Okay, now can we do something else using this same pointer? Yes. Okay, we'll see this. See, since this guy is a pointer, since this guy is a pointer whose contents I would generally change during runtime. Okay, so as a programmer, हम क्या कर सकते हैं? Like you will have a pointer which can point to some object at some time, and you do some operation on top of it. And once you are done, what you do, you use the same pointer and point to something else. Okay, generally what we will do, pointer plus plus we will do, pointer minus minus we will do. So whenever you are counting number of bytes in a string or number of integers in an array, something and all, what you would do, you would use an array. I mean, you use a pointer to point to the array. Okay, now the pointer can point to any type of object. So pointer can just hold an address. So that address can point to any type of object. Okay. Now during runtime, how do we identify what type of object it is actually trying to point? Okay, that is why we can see. Okay. Now what we did here, okay. Now can you tell us what we did here? Here, what we did, we just assigned a
Means
base class
assign the
of
derived class only. Yeah. At
object
the
to this.
instead of base class, you are derived class, right?
Mm.
We'll check it out.
Okay. So here what we did, we just assigned a obj. Okay. Then after that what we did, after that what we did, we deleted that object. मेरे को ये base class nahi chahiye. I mean, whatever the object that you created here, right? This is no longer required for me. Okay, I just deleted it. Okay, I created an object, I got the name, I just deleted it. But my pointer is what? Is a static variable. My pointer is a static variable, okay, which is pointing to a dynamic object. Okay, now I made it point to what? A derived class. Okay, I made a pointer point to a derived class. Okay, So, and I'm just trying to print what is the type of it. Okay, now let's see what happens. So here it should print, it was base class, like 9 base class it was printing. Let's see what it prints here. What should it print? Something like
10,
10 derived
10
class,
base
or
class.
uh, 10
10
derived
base class
class.
only it will be.
Yeah, something, maybe some dummy number followed by the type. Okay,
Yeah. Not to
see
be.
here, what did it print? 9 base class. Then you did a delete, right? You did a delete, the base class got destroyed. Okay, then you created an object. What you did here, you created an object in line number 70. You created a object. Okay, you created an object, so it's saying base created, derived created. उसके बाद you are trying to print, you are trying to print the name of the class, which is nothing but 12 derived class.
Mhm.
12 derived class. So during runtime, what are we able to achieve? The pointer can point to anything. Now you made this base, it is pointing to base. Now you made this pointer to derived, it is pointing to derived. Okay, I can identify what is it that I am actually trying to point to. Okay, so this was derived class, and then you see derived destroyed, base destroyed, scoped object list. So this is some dummy code, dummy results is not required.
And if you mention that delete some object means it will be destroyed or what?
Which one? This one, right?
That,
Delete
yes,
pointer means
delete base.
this will be destroyed. This memory will be freed. Whatever the memory that got allotted here, right? That got
Mhm.
freed. It is similar to malloc and free.
But previously you had done like a return some tilde operator and that class means ability to
Uh,
mention means it will come destroy.
that is for scope.
Oh,
That is for unique
oh,
lock.
scope
uh,
dresser.
Scoped here, here. This is for unique. This one, scoped
Mm-hmm.
objects, right? So you would have
Means
seen these locks, right? You are already seeing these locks already here. You would see here base
mhm,
class, base created, derived created.
mhm.
This is the log for this, and you also did a same base object creation and derived object creation here. So you would see the same here. Where is it? Base created. Okay. Base destroyed.
Okay, means
Base
inside
create.
the scope if you destroy means you can using that return tilde operator, right?
I still didn't get.
So, means previously we had used the tilde operator, return tilde operator and some class name or object name. It will be destroyed like that.
So this is what it is. This is the
Yes, yes,
destructor.
yes.
So these are the destructors.
Destructor. Okay, okay.
So you don't need to write this in your code. Compiler will put it. Okay. For a statically created object, this one. For this object, okay, compiler will put it. Okay. Now if you see, I commented this. I'm running here. Base created, base destroyed, base created, derived created, name of it, derived destroyed, and base destroyed. So you are creating and destroying objects in a right way. Okay. Now we'll see. We'll comment this delete and this delete. Now what should happen? It should create and create. What should
Yes.
happen? It should
Only create only.
only create. You should not see
Destroy.
any deletion. Now what is that called? What is that problem called? You are just creating and not destroying. What is that called? That problem called? So you created a memory, but you didn't release it. What is that called?
Memory leak.
Yes. So it is just called memory leak. So the right way is create it, delete it. Okay. So runtime type identification. How to do a runtime type identification? You are able to understand what is this, right? This concept, what compiler can do, right? Now we'll discuss some problems and real problems that we face here. Okay. So any more doubts on this? Okay. Okay. I'll take this as a no. Okay. So one important thing that I always want to start is when you are writing a class, okay, generally the right way of, I mean, the general way of writing people will do is they just create a constructor, they just create a destructor for it. What they do, they just create a constructor, they just create a destructor for it. They will not write the keyword virtual here. They will not write a keyword virtual for the destructor. Okay. So what is it? Okay. Why we need to declare destructors virtual? Okay. Now we'll see the same example. Everything is working fine, right? The same code. I'll not make any changes to whatever the code that we had. Now we see what happens. So the base created, base destroyed, base created, derived created, base destroyed. I didn't save the file. Okay, I didn't save this. Okay, sorry. Please refer this log. What we see here, base created, base destroyed. Base created, base destroyed. Derived created, derived destroyed. Derived destroyed. So whatever you see as created got destroyed. You are not seeing any memory leaks here. Okay. So whenever you create objects dynamically on heap, okay, you would always see memory leaks, either via direct. You can identify the memory leaks by looking at the code which you have actually written. Sometimes you would see memory leaks in the libraries or the implementations that they are given, or the classes that you can say that they, you can call them as implementations or libraries, whatever. There you can see some memory leaks. Okay, and you would get into those memory leaks and you should debug and find out what it is. Then you will still not be able to find the bug. Okay, so here I have used the keyword virtual. Why? Why is it? See, what does virtual allows you to do is, okay, virtual would actually allow the okay, the derived objects to overwrite the instances. Okay, it will allow you to overwrite the any functions. It will allow you to override the any functions. Okay, that you have written here. But let's not get into deep of it. But let's just check this and see what happens here. Now I just removed the keyword virtual and I saved it. Okay, I just removed the keyword virtual. Okay, and I saved it. Now let's see here it was 9 base, it was 12 derived before making changes. Now let's see. Now I compiled the same code. Now I'm compiling the same, running the same code. Only thing that I did is I removed the keyword virtual. What did I do? I just removed the keyword virtual. Now if you see the results, you see 9 base, 9 base is fine. Base destroyed, base destroyed is fine. Now base created is fine. Derived created, derived created is fine. Now you see the difference. The name. Runtime, you are trying to identify the type of the object. In runtime, you are trying to identify the type of the object. Okay, with virtual keyword, it was printing derived class. I removed the virtual keyword. What happened? It just printed it as base class. So how can it print it as base class? Any idea? Okay, I'll tell you. Because what you did is you declared a base pointer. You declared a base pointer and you are assigning objects of either base or derived and all. Okay, when you assign a derived object to a base class, the runtime type identification is carried over by there is something like virtual v pointers and all. Using that, okay, the compiler will be able to find the type of it, actual type of the objects. Okay, so what we are actually trying to call here is when you do a delete, when you do a delete, what we are trying to call, we are trying to call the destructors. Okay, or in this case we are trying to call uh, the name of the object, trying to get the name of the objects and all. So what happens in these two cases, right? When you remove the virtual keyboard, the vpointer tables, okay, they are not properly initialized, or the destructor is not actually allowed to be overwritten. Okay, so the moment you remove the virtual keyword, or at least if you have a class which has a function which is at least which is having one function as virtual, right? During runtime you can actually assign the type of it. Okay, during runtime you can actually assign the right type of it using the pointers itself. Okay, now if you see, if I retain the virtual keyword, okay, now if you retain the virtual keyword, what will be the result? It is able to identify the actual type. Okay, so it is actually able to identify the type during runtime also. So just by adding virtual keyword, we are saying this objects pointer, that are whatever you are creating, right? uh, it can be modified, or it can be pointed by someone else, some other pointer types also. Okay, now let me add a dummy function here.
Sir, we have used the virtual keyword in base class. Why it is affecting to that derived class?
It is actually not Sorry, just one. Okay. So to your answer, I'll answer your question. I answer it. So you said why is it affecting derived class, right?
Yes. Yes.
So it
Yes.
is actually not affecting derived class. It is not affecting derived class. It is not able to. It is affecting the base class pointer.
Observe. Okay.
It is affecting the capabilities that a base class pointer can give you. Okay. Now, if I make this as a derived class pointer, assume I make this as a derived class pointer. So this is a pointer, right? Derived class pointer. Okay. What did I do here? Virtual. I'll remove the virtual keyword because when we remove the virtual keyword, that is when we are having problems. So now what should it do? What should it actually print?
Derived class.
Derived. So that's happen. That will happen. See, it is printing derived class. So you don't see any problem
Mhm.
with derived class at all. The problem is not with the
Yes.
derived class. The problem is with the capability of a base class pointer.
Mm.
I'll just copy this. So,
Also, it depends on the pointer.
yeah, it depends on the pointers. The pointer का
Yes.
capability क्या है? How we can add more capabilities to a pointer. Okay, that is a concepts or that is using that is what we can really achieve RTTI runtime type identification. Runtime में आप एक type को कैसे identify कर सकते हैं? So it's not like compiler should do. It is like the developer should also do something, okay, which compiler cannot. Okay, you got what I'm trying to say, right? Okay,
Yes.
there
Yes.
is a limitation in C++. There is a limitation in C++ that all the functions that you declare are normal functions. They are not virtual functions. They are not virtual. Now, if you take the same code and compile in Java, okay, same code you write in Java and you compile it, you would not see that problem because no matter what you declare, everything is virtual there. All functions are virtual. Okay. So now what is this virtual? What is this guy can give us? Okay, and all we'll see here. Now I just declared one function as alien. So earlier what we did, we declared base class as virtual. Okay. Now when we declared base class as virtual, it was able to identify the type during runtime. Okay. Now I removed virtual keyword from the destructor. Okay. Now if I add a virtual keyword to any other function, can I get the same property for the pointer or not? We'll see. You got my point, right? See, you can ask me a question like, should I write virtual to destructor only or virtual to any other function can I write? That is a question that I wanted to ask. Okay. Okay. Now if you see here, First thing, you created a base class, then here it is pointing to a derived class, and then derived class. See, now if we should see the code as well. So the base object was first pointing to base, then the base was next pointing to derived, then I created a derived object, okay, which is pointing to derived, derived pointer, which is pointing to derived object. Now if you see, this code will work as a developer wants. I would like to repeat, this code will work. When I say this code will work, this code will be able to do runtime type identification. This code will be able to do runtime type identification if if at least at least one function at least one function in the class is virtual. Okay, if you made at least one function as virtual, the pointer will it gets its properties. Okay, like RTTI का prop capability pointer को आएगा. Okay, but why I wrote this virtual to destructor only? Any answers or any guesses on this? Any answers or any guesses?
Inside the base function, we can create anything, means using that virtual keyword.
Mhm. I can create, but why I declared virtual to base class only? Or why would
Because
I?
base class is, if you change the public, private, and protected,
Mm,
but the base class it will be.
no, may not be no. So what does a class?
Only virtual is done the destructive part, right?
Yeah, I have given virtual to destructor only. Why not to others?
Uh-huh.
Or why would I recommend you, whenever you are writing a class, why would I recommend you to write a virtual? Okay, I'll answer this. Okay, why would I recommend anyone developers to keep their destructors as virtual? Is simply because whether you write a function or not, whether तुम्हारा क्लास में functions हो या ना हो, okay, destructor तो जरूर होगा. Destructor will be always there, right? Constructor definitely होगा, destructor definitely होगा. Okay,
Yes, yes. If it is created, it will be destroyed.
correct. Created means the when you declare a class, you would have a constructor, and destructor also by default it will provide. You can just add it as virtual. So it's always recommended to put the destructors as virtual, just because to assure at least one function is destructor is declared as virtual, then the runtime capability is given. Okay, if I make other functions as virtual, okay, if any one function as virtual, right, then this function can be public or private. Okay, then you should always struggle, like, is this public, private? Someone can inherit it as public, someone can inherit it as private. All these problems you can create. Okay, what if I make this as, okay, I made this as virtual. Okay, but when inheriting, I inherited it as private. Now what will happen now? Now I will create one more class which is derived. Now that guy will not have access to this. Okay, because that is private. What I mean to say is, uh, either I have written this. Okay. Now what I did here is, so I made the base class as private, privately inherited here. Okay. Now second will inherit derived as public, but derived is inheriting base class as private. Now here, okay, I cannot call the actual here. Why it will say, see here, no operator tilt matches this operations. Operand not derived class. See, it is saying the declared at line 4, this is inaccessible. Okay, the base class ka destructor is inaccessible. Okay, now let's try to make it public. See, that error has gone. Okay, now forget about this. Okay, you are calling the destructor though. This this you should actually call something like delete. Okay, so you in the second order derived, okay, you are trying to call the destructors. Okay, you will get errors if you make this as private. So to avoid all these problems, right, you make this guy as virtual. Okay, whether this function is visible or not, this guy will be visible to all. Okay, this guy will be visible to everyone, and you will not see any issues there. Okay, that's why anyone would recommend why destructors are virtual always. Okay, any more questions, guys, on this? RTTA is a lengthy concept. We might need 2 more classes to cover this up. Okay, what I wanted to cover here is like some recap for inheritance, and how do you create a pointers for a class and pointers for a derived class. Okay, now when creating pointers, what kind of problems you can encounter? Anyone has any questions?
No, sir.
Okay, I think we can. I think that's all. Maybe we can end this. Okay, that's all, guys. That's all I had for today. Okay, I think there was one more. Yeah, we will cover something else on Monday. Sunday we don't. Let's not have any class. We'll do it on Monday. and try to find some problems on inheritance and virtual keyword. Okay, inheritance and virtual keyword in C. Okay, come prepared for next two classes. Only these two classes I wanted you to come prepared. Okay, and I want you guys to ask more and more questions on this topic, because C++ is all about
RTTA
this.
and inheritance, right?
Sorry.
This RTTA and inheritance, right?
Yeah, just RTTA or virtual keyword. What does virtual
Uh-huh.
keyword or RTTA, what does it mean
Mhm.
in C++? Come prepared, ask me as many questions as possible. Okay, so that you are completely uh, underst have and you can get complete understanding about this. See, your interviewer will always set this as a very much barrier. If you are able to answer all each and every questions in virtual keyword, right? So out of 1 out of 10, this is something like 4 to 5 marks that they will put you. Okay. So if you are able to answer all the questions, right? Like क्या होता है, like you have exams of 100 marks. In that you are getting a questions uska value itself is 50 marks. Okay, and it can put you in pass and fail sections. So this is has a lot of weightage. Okay, your algorithm skills or everything, people can neglect. Okay, but your this virtual keyword or overloading or runtime type identification is something which is very much important. Okay, this is boost. So if you just answer every questions with respect to virtual, then something you have answered for assignment operator, copy constructors. Okay, they become plus. Then friend function is something else. So if you answer all this, then done. Rest is like STLs, that is not part of C++, that is part of data structures, concepts and all. Okay, then OS concepts. So if you answer these 5 or 6 questions, right, your C++ you have cleared. Then next would be data structure questions and Linux questions. Okay, so that's what I wanted you to come prepared means you study this concept even before coming to this class. Only this one. I'm not asking you to study everything, but only this one topic. Okay, what is virtual keyword in C++? That's all, and nothing else. Or you can say this one, virtual functions or polymorphism. Okay, I'll do this class, but I want you to you guys to identify, come up with some questions so that I can cover more on this. What is virtual functions and v pointer, v tables, no. Okay, so because if you don't understand this virtual keyword, there is nothing that you can do in exceptions or in C++. Okay, that's all, guys. Right. We will see you on Monday. Thank you. Thank you all.
Okay.
Thank